title of this set of notes is Ellipses, and the outcome is to be able to graph an ellipse that is either on the origin or centered off of the origin. So first we're going to look at what is an ellipse. You have a picture here that shows a graph and ellipse. There's a couple of vocabulary words that you're going to hear over and over and over. So first we have the center of an ellipse. It's in black here. And then you have in purple what are called the vertices. Those are the points that are the furthest away from your center. The distance between your two vertices in red is called your major axis. Sometimes we only want to know half of that from the center just out to one vertex. So if we want just half of it, we call it the semi-major axis. Semi for half. So the major axis is from vertex to vertex. The semi-major axis is from center to vertex. Then in the perpendicular direction, we have the minor axis. It's the smaller of the two axes. And at the end of the minor axis, this picture doesn't show it, the points there, those are called your covertices. Covertex is singular. Covertices is plural if we're talking about both of them. And then we also have these special points that are always on the major axis called your foci. Focus for one of them. Foci woci would be the plural. And what's so significant about these points is that they actually create the ellipse. What's interesting about an ellipse is that I can take any point on the ellipse. Let's choose that point there in blue. Take any point on the ellipse, and if you measure the distance to both foci, so let's say I call this distance, let's call it x, and let's call it this one y. X plus y equals some number, and that number is consistent around the entire ellipse for any point that we choose. So there are some details that we need about an ellipse, and there's a really good graphic in your textbook on page 927 that this is grabbed from if you're having trouble seeing this. So an ellipse has an equation, and the basic equation is x squared plus y squared, x squared over a squared plus y squared over b squared equals 1. And I want you to notice that a and b can change places depending on whether you have a horizontal or a vertical ellipse. A is always the larger of those values. So the way I remember is I just look and say, okay, is the biggest number is under x, then it's horizontal because x is on the horizontal. If the larger number is under y, then it's vertical. You can find your foci. There's an equation. If a and b are the denominators from your ellipse, then the foci are found by c squared equals a squared minus b squared. So those are the key things to get from this graphic. Some other interesting information. We already talked about c squared equals a squared minus b squared. You don't need this picture, but it does show you why the formula works. But this is your formula for your foci. You're going to end up having that memorized. Your major axis, like we talked about in that picture, is double the length of A. A is the distance from the center to a vertex, so double that is the length of the entire major axis. And likewise, the minor axis will be 2b. There's one other measure that I want to talk about for your notes, which is called eccentricity. And the formula for eccentricity is E equals C over A, where C is coming from the foci and A is coming from the original equation. C over A, the eccentricity, just tells you how crazy your ellipse is, right? You think about eccentricity. So if E equals 0, that is the most boring ellipse you can have, that is a circle. As E gets closer and closer to 1, your ellipse is going to get flatter and flatter. So remember, our goal is to be able to graph an ellipse. So to graph an ellipse, you first want to figure out what the orientation is. And you're going to do that by looking at the denominators. Whichever term has a larger denominator, the x term or the y term, that tells you the orientation. X term has a bigger denominator, horizontal. If the y term has a bigger denominator, then it's vertical. You're then going to solve for a and b. Remember that in your equations, the denominators are a squared and b squared. And that can be a little tricky sometimes because we want just a or just b. And the reason we want a or b is so that we can actually go to step 3. They're going to tell us where to graph our vertices and our co-vertices, and then we're just going to do our best to draw an ellipse. So let's actually do an example together. So let's graph this ellipse. So we have x squared over 4 plus y squared over 9. So first thing I notice is that my denominators, this one is larger, and it's below the y squared term, so that tells me that this is going to be a vertical ellipse. So I want to know what a and b are. The larger of the two numbers is always a, so that denominator is a squared. Remember, if you go back to the vertical ellipse on page 927, that's the equation. So that denominator is a squared. That's a 9, which means that a equals 3. And then the other denominator is b squared. So if 4 equals b squared, then b equals 2. And that tells me how far my vertex or my co-vertex is from the center. So if I'm going to graph this, I'm going to start at 0, 0. That's the center of this ellipse. And my vertices, which are a, are 3 away from the center in the vertical direction. So I'm going to go up 3 and down 3. And I'll label those points. Label your points correctly. That's 0, 3, and 0, negative 3. And then the co-vertices come from B. They are 2 away from the center. So I'll go right 2 and left 2. And then once I have all that information, I can do my best to make it look like an ellipse. This is on graph paper, it'd be scale a little better and would perhaps look a little more elliptical. But if I'm drawing it, it's probably always going to look a little eggish. The other thing we need is, let's see, so we've graphed the ellipse. It says identify the vertices on the graph, which we've done here. It also says to identify the foci on the graph. So remember, to find foci, we have this equation, c squared equals a squared minus b squared. So a is 3, which means a squared is 9. B is 2, which means b squared is 4. So 9 minus 4 is 5. C squared equals 5. I can take the square root on both sides of the equation. I get that c equals the square root of 5. Don't worry about simplifying it. Square root of 5 is a little bit more than 2. So on my graph, I'm going to go a little bit more than 2 and a little bit more than 2. And I'm going to label those points. This point is at 0, radical 5, and that point is at 0, negative radical 5. Remember that your foci are always on your major axis. Always, always, always. All right, the last thing we're asked about is the eccentricity. And eccentricity equals c over a. And we just solved that c equals radical 5 and a equals 3. Be very careful that you use a and not a squared for your eccentricity formula. We can't put eccentricity on the graph, it's not there. So that's it, we're done for that example. We could also go the other direction. So here we have a graph, this nice elliptical graph. What's its equation? So I can tell that this thing is horizontal. So a is going to go under the x term, and a is 3. So I'm going to have x squared over 3 squared. And then in the vertical direction, the distance between the center and the co-vertex is 2. So 2 squared. And all ellipses are always going to equal 1 at the very end. And then let's simplify this. X squared over 9 plus y squared over 4 equals 1. And we can actually check here. Look at that. That is the answer we were supposed to get. So I want you to try one more. And I want you to try this one on your own. Pause the video, see how far you can get. And then when you're ready, unpause the video and I'll have the answer showing. Right, the last thing I want to talk about is ellipses that are not centered at the origin. So here we have an example. And look at the equation. The center comes from the numerator. Do you remember when you were graphing parabolas, you would move the vertex? This is very similar to what's happening there. You're going to move the vertex in the opposite direction of what's in the numerator. I like to remember if everything that's in parentheses is always backwards. So this center, instead of going +1, it will go -1. And instead of going down 3, it'll go up 3. So that's at -1, 3. And you can see here in the graph that's exactly where it is. Then the A and the B work the same. This thing is horizontal because the x term has a larger denominator, and the distance between the center and the vertex is still 3 units. We can see that there, 1, 2, 3. And then the distance between the center and the co-vertex in the vertical direction is 1 unit. So everything else is going to work the same. I could still find my foci. Still going to be c squared equals a squared minus b squared. A squared is 9, b squared is 1. So c equals the square root of 8, which is a little bit less than 3. And I can see here that my foci would go in the horizontal direction on the major axis a little bit less than 3 away from the center. And the way you would label this point is it started at the center's at -1 on the x-axis, and then this is moved right, radical 8. And the y value, it's still 2 above. So that's the coordinate, -1 plus radical 8, 2. And then over here, likewise, it'll be -1 minus radical 8, comma 2. So notice how the center and the foci, really similar. The only difference is I stick a plus or minus radical 8 because that's the c value. So that's it for your notes. We are going to be using these for the next few classes. Come in ready to graph ellipses. We're going to start with just ellipses at the center next class.